Good evening, everyone. I'm Nidhi Jain, one of the founders of Fluid Robotics. We are a global wastewater analytics and infrastructure surveillance company, helping our customers achieve their goal of becoming water resilient. The problem that got us started was the amount of wastewater that gets discharged into the environment, largely untreated, polluting our lakes and rivers, and also being a detrimental threat to our public health. In Indian cities, 50 billion liters of wastewater is discharged into the environment every single day. And this problem is not just limited to developing countries like India. United States witnesses 9 billion liters of sanitary sewer overflows every single day. The root cause of this is majorly the aging pipeline infrastructure and a lack of a scalable technology for cities to routinely inspect their sewer infrastructure to help them prevent sanitary sewer overflows. Our solution is robots and multi-sensor devices that are deployed in the field for data collection to do condition assessment, and along with our data analytics framework, our customers get insights into the sewer network to monitor the health of the wastewater infrastructure and also the health of the waterways. Our solution enables our customers to make better decisions by pinpointing critical areas and also help them in budget maintenance and resolving issues where it's most critical and urgently needed at the moment. This is one of our robots that's being deployed in a pipeline. So we deploy our robots directly into the infrastructure, and as they are traveling, they collect data, they monitor the effluent quality, and also do condition assessment. We have used this approach, I would like to get into detail of using this approach around lakes and rivers. So what we have done, so to monitor the storm drains, the amount of discharge that they are untreated wastewater that they are carrying into the lake or rivers, first we deploy these robots into the storm drains. These drains can be either piped drains or open nalas. Often these drains are very difficult to access and are very dangerous because of the presence of chemical toxins and gases. So our robots do the condition assessment of these drains and also understand the volume of the untreated wastewater that is flowing through it. It also understands the quality that is flown, whether it's an industrial waste or domestic waste. Once we have understood that, we deploy our robots in the sewer infrastructure adjacent to these storm drains to understand whether they are connected to a sewage treatment plant. Do they have a capacity to take extra wastewater? Are they in good condition? Once we've collected this data, it gives us to take a network optimization approach. We can then see if we can optimize the existing network by connecting these drains to a piped sewer network so that the wastewater can be scalably and sustainably intercepted and diverted to an existing treatment plant. We have piloted the solution in 12 cities across India and have monitored 1.3 billion liters of urban pollution. This network optimization approach has a huge savings for the cities. Instead of building new infrastructure and building new sewage treatment plants, they can often reuse the existing infrastructure. In the past 1 year, we've also seen an increase in programs across the country for wastewater surveillance for COVID monitoring. But most often, these samples are being collected manually, which, most often, a sanitary worker will will collect the sample and transport it to the lab. This has significant risks, like risk of sample contamination, a risk of exposure to raw sewage, and also preventing from composite samples being taken most often over a period of 12 to 24 hours, because they have to be stored at a specific temperature to ensure RNA preservation. With our expertise in building devices for wastewater, we could very quickly build our robotic samplers to solve these problems. We are currently deployed our automated samplers in 3 cities across India and monitoring 12.5 million population. Our robotic samples solve the problem of, are scalable, sustainable, and allow the sampling process to happen safely and has scientific rigor. Our prominent partners include AIMS, NCL, and Government of India, who are helping us deploying our solutions across different cities. The company was founded by Aseem Bhalerao and myself. Aseem has a prior experience of working with underwater robotics and surgical robotics prior to starting Fluid. I have 15 years of experience building software and products for companies like Qualcomm and other startups in the Silicon Valley. Both of us were based in 12 years in US before moving to India to start Fluid Robotics and to solve this problem of urban pollution. And we are thankful to a great set of partners who have helped in our journey to build scalable and impactful products. I'm very happy to say that today, our solution is present in 4 countries. In the last 1 year alone, we have monitored 1.5 million feet of sewers. We have monitored 1.3 billion liters of urban pollution. And currently, we are monitoring 12.5 million population for infectious diseases. We are very thankful to our customers for providing continuous feedback and helping us to build these products with positive socio-economic and socio-economic impact. Lastly, if your cities are suffering, if in your cities, if your lakes and rivers are suffering from health issues, we would like to partner with you and take this data-driven approach to improve the health of our water bodies. Thank you.